This is question 11 on problem solving from section 1 of the 2019 ECAA. So we're told about this card game where 9 cards numbered from 1 to 9 are laid out in this square. If player 1 chooses 2 adjacent cards and scores the difference, and then player 2 chooses 2 of the remaining adjacent cards and scores the average. Therefore, based on this particular arrangement, how can Alex play to achieve the highest score possible while making sure she definitely wins? And we're given 5 different actions. So what's a foolproof way of going through this? Well, for each of these, if we play what we're told for player 1, then if we can find a player 2 score that beats this, then we know it must be wrong because we know that she needs to win. So let's set up something of a table, come up with all the player 1 scores and see if we can identify a player 2 score while following the rules that beats player 1. So firstly, our score from choosing 1 and 8 as player 1, what would that be? If we're scoring the difference is 7. And then what can player 2 do? So it's the 2 remaining adjacent cards, so let's get rid of 1 and 8 on the grid. Can we find a way for player 2 to win this hand? So if they're scoring the average, then we want to choose the 2 largest cards possible. The 2 largest adjacent cards are 9 and 7. That would give us a score of 8. So we know that if Alex chooses this option, then she won't definitely win if player 2 spots this, and so this isn't what we want to do. Now if we repeat this analysis for the second one, so we're playing first and choosing 3 and 9, what score does that give us as player 1? The difference between 3 and 9 is 6. And then what can we do as player 2 to beat that? So if 3 and 9 have gone, then what are the 2 largest adjacent numbers? So that would be 6 and 7. What score would that give us? The average between those 2 is 6.5. So again, we've managed to beat player 1, and we know that therefore this must be a wrong answer. So moving on, if we play first and choose 6 and 7, what's our score as player 1? Well, that would only be a difference of 1, so I don't know why she'd choose that. But if she did, what can player 2 choose from? If we get rid of 6 and 7, how can we make a bigger score than that? Well, there are a number of options, but the largest one would be choosing 3 and 9. That would give us an average of 6. So we can definitely beat a score of 1, so this definitely isn't the correct answer. Now for our fourth option, what's our score if we play first and choose 7 and 9? Difference between 7 and 9 is 2. And if we take off 7 and 9 from the table, can we beat a score of 2? Well, again, there are a number of options. If we choose 3 and 6, we get a score of 4.5. So we've beaten this, and therefore this isn't guaranteed to be a winning score, so we can't choose this option. So this leaves us with only option E, which is to play second. And so by going through these, we've shown that it's pretty likely that it's not possible to win if you play first, and that requires the second player to choose a larger score, of course. But the only way to guarantee that you can win in this particular hand of the game is to play second. So this corresponds to an answer of E.